good morning, good afternoon, and good evening, and welcome to the Grand Challenge finale of the ITU, Artificial Intelligence Machine Learning for 5G Challenge. My name is Reinhard Scholl from the International Telecommunication Union in Geneva, and I have the privilege of leading you through today's program. ITU is the United Nations Specialized Agency for Information and Communication Technologies. ITU makes standards. ITU allocates frequencies to the services that make use of the radio communication spectrum. And ITU assists developing countries in setting up their communication infrastructure. And ITU organizes the Machine Learning in 5G Challenge. Today is the big day where winners are declared and where we will hand out several prizes. So today we will give the spotlight to the 13 best solutions. We had over 1,600 students and professionals registered for this year's challenge, and in the first round, judges determined the best teams, and of those, the top 32 teams were invited to present a solution in front of a judges panel in a 3-day event from 30 November to the 2nd of December. Of these 32 teams, the best 13 teams are invited today to present. Each team will be given a 3-minute slot to present. And then we will hand out several awards and certificates. So the winner of the first prize will receive a cash award of 5,000 francs, the second prize of 3,000 francs, third prize is 2,000 francs, and then we have 3 runners-up who will receive a cash prize of each 1,000 francs. Furthermore, there will be half a dozen of teams who will receive an honorable mention award and a cash prize of 300 francs each. And we will also hand out a couple of mentors encouragement certificates to young student teams. And we will also do a public poll right after the presentation of the 13 top solutions. So the public can choose its favorite team among those 13 top solutions. And for these, we will be using not Zoom, but we will be using a different tool called Pigeonhole. But we'll come to that point after we have heard all the presentations. And the winner of the public poll, we will award with a cash prize of 500 francs. Of the 32 teams who have not received one of the above awards, all will receive a certificate of participation. So that's the meat of today's session. And to start off, it is my great pleasure to welcome the director of the Telecommunications Standardization Bureau in ITU, Dr. Chesa Blee, for his welcome remarks. Chesa, thank you for joining.
Yes, thank you very much, Reinhard. Very welcome you, everyone. Really happy to now we are reached of this last day of this our grand finale. This year edition of this AI Machine Learning Challenge is the second edition actually of our competition. Today marks the end of the global competition with an online prize winning event. Our adventure started at last year, the beginning of last year, has turned into a great experience, which will also continue next year. During last year's challenge, we had participants from 62 countries. This year, we received participants from 82 countries. We also published a special issue of the ITU Journal for Future and Evolving Technologies with the 10 best peer-reviewed papers resulting from last year's challenge. The call for paper for a special issue from the best papers of this year's challenge has already been launched. So I would like to encourage you to submit a paper for it. So the deadline to submit the paper is 31st January next year, year 2022. This year, the best 32 best teams made it to the round, which took place from 30th November until 2nd December. So from the feedback I received, several state-of-the-art solutions were showcased during those presentations. I'm very keen on having those solutions contributed to the ITU standards work, and also published in our ITU journal on future and evolving technologies. Through the challenge, ITU encourages and supports the growing community deriving the integration of AI machine learning networks, and at the same time, enhances the community driving ITU standardization work for AI machine learning. The ITU challenge enables the collaborative culture necessary for success in emerging and future networks and creates new opportunities for industry and academia to influence the evolution of ITU standards. I'd like to thank the sponsors of this challenge, as well as the Ministry of Science and ICT of the Republic of Korea. I'd like to thank our technical partner, AIIA, the Artificial Intelligence Industry Association of China. I'd like to thank the experts who have made their time and the knowledge available to generate problem statements, to be on the challenge management board, and to be on the judges panel. And of course, I'd like to thank the many participants who signed up for this year's competition and who submitted solutions. I will see you again for the award ceremony later in the program. So I really pleased to join of this event. So back to Reinhard.
Thank you, Chesap. See you later again. And now we are happy to welcome one of the two sponsors of the challenge. We had two sponsors who made the challenge possible. One was the company Xilinx, and our other sponsor was the Ministry of Science and ICT of the Republic of Korea. So I'm now very happy to introduce from the Ministry of Science and ICT of the Republic of Korea, Mrs. Ji-hyun. She is the director of the Multilateral Cooperation Division of the ministry. The Ministry of Science and ICT of Korea has long been a strong supporter of ITU, and so we are grateful that Korea also decided to sponsor this challenge. So please, Mrs. the floor is yours. If you can turn on your audio, then Mrs. your audio is off. Yes, now it's working.
Okay.
Good.
Thank you. Good morning, good afternoon, and good evening. I'm really honored to take part in the Grand Challenge finale with ambitious participants from all around the world. First of all, I would like to extend my gratitude and congratulations to ITU Secretary General Corinne Zhao and TSB Director Jessup Lee for successfully organizing the second AI machine learning in 5G challenges this year. I would also like to congratulate the 32 participants who made it all the way through to the grand finale today. Of course, the 1,600 participants from 82 countries have my all admirations and respect. You are all winners. My appreciation also goes out to the university and the businesses for providing excellent program statements and participants in the evaluation process. Over the past 2 years, COVID-19 turned out our world upside down. Holding a virtual event like this would have been very rare before the pandemic. The COVID-19 crisis indeed speeding up changes our lives. The development of communication networks is what made these changes possible, connecting the world and allowing young talents and experts compete and communicate with one another. 5G is a key element of these changes that improved network speed and expanded connectivity. As you know well, Korea became the first country to launch 5G commercial networks, and it's opening new horizons of communication networks. Also, Korea is making endeavors to become inclusive digital nation, promoting digital services that can bring tangible changes for all. This is closely related to one of the ITU's key values, connecting everyone in the world. There is a Korean proverb, a bead will be useless if one does not thread it. It means even if you have many resources, they will have no value if you do not make use of them. Data is said to be the new oil of the 21st century. Just like oil, data needs to go through many steps of refinement and processing to create quality data that create trustworthy new services in the world. Artificial intelligence and machine learning are an integral part of data refinement, processing, and validations. The AI in machine learning in 5G challenges, where the participants use the AI and machine learning to solve problems for realizing the potential communication networks, is the process of threading beads. And I believe this event will pave way for the future. I really hope the AI and machine learning in 5G challenges is a good opportunity to enhance our capabilities for communications, AI, and machine learning, which are at the center of the rapid digital transformation, and expand your experience with other parts of the globe. Some say that challenge and competition create hopes and vitality. I would like to give applause to all of you for your passion and courage. Thank you very much.
Thank you very much, Mrs. And I'm confident that we will have strong participation from Korea in next year's challenge. Now, let me introduce two dear colleagues who have managed the entire challenge and much more. This is Thomas Pascalo and Vishnu Ram. So Thomas and Vishnu, could you perhaps turn on your videos? And yeah, thank you very much. So Vishnu will be hearing towards the end. He will give an outlook of the challenge in 2022. And now we will hear Thomas giving us a snapshot of what happened in this year's challenge. Thomas?
Thank you so much, Reinhard. I will go through quickly some highlights for the 2021 ITU AI and Machine 5G Challenge. First, I'll go through why the challenge. One of the most interesting things that we would like to achieve with the challenge is to create a community of value, where we can take problems in communication networks and then create solutions using machine learning. And also we need to create a community that can do this. So this is one of the challenge, one of the activities that we would like to achieve, but also we are engaging students and professionals or researchers in IT work. And this year, most interesting thing, we had a problem statement that was presented by focus group on autonomous network. So it's more or less like an incubator for standard activities, which is helping ITU to achieve one of its core values, which is standards development. And from this, the participation, we asked our participants why they chose to participate in the challenge. As you can see from the graph on the screen, most answers was publication opportunities. So our participants would like to publish their work. They would like to get training opportunities as well as to collaborate with others from different parts of the world. Of course, prizes are there, but it's not the biggest aim for participation in the challenge. And in terms of satisfaction, we have 92% of participants that they would like to recommend the challenge to either a colleague or a friend to participate in future. And also almost 90%, there's 90% satisfaction rate that most people are satisfied with how the challenge is going. And I would also like to highlight that in this challenge, most of the participants are students. We have some undergraduate students, master students, PhD students, as well as professionals. So these are seasoned researchers in companies and in other institutions that are doing this kind of work. And during the part of the challenge during the year, we give out expert talks, which are webinars that we gather from experts from the industry as well as professors from different academic institutions. They give out webinars, but on top of these, we also have roundtables, hands-on session, mentorship, as well as some problem statement. They give out baseline models, which helps to participants to move quickly in terms of understanding what the problem is, how they can tackle the problem, and then from there they can build the momentum to solve the problem that have been given for the challenge. And this is rough timeline. Basically, for this year, we started in around February to May to create the problem statements. We had the competition phase from June to October, and then the grand challenge finale. There was 3-day event that happened from 30 November to 2 December. And then today is the final event, which is the award ceremony. We are going to award best solutions for the challenge in 2021. And some of the numbers that I would like to highlight, we had over 1,600 participation from 82 countries, 32 finalists that presented their solutions during the final presentations on 30 November to 2 December. And we had 16 open challenges. Two were strictly in China, but 14 were from different problem statement hosts. And we have this year, we are lucky that most of the participants managed to open source their solutions. So we have 36 GitHub repositories that you can see. Together with last year's solutions, we have more than 70 GitHub repos with all solutions from last year's challenge, this year's challenge. And of course, we also, I would like to highlight that one team from last year, after they published their paper, they open source their code as well, including what was added for their paper publication. And I would like also to thank our sponsors, Xilinx and Ministry of Science and ICT, Republic of Korea, for the sponsorship during the 2021 edition of the challenge. And also I would like to thank ITU, my boss, Reinhard, Chesab, and all the ITU management for being there for us, organizing this challenge. And also a big thank you to our partners. We have Xilinx, who was a host for a problem statement, Barcelona Neural Network, lastly, this is UFP in Brazil, University of Fabra in Barcelona, North Carolina State University, Tuxel, SBSUT in Russia, ZTE, China Unicom, Rising Japan, NIST in US, University of Alabama in US, ADGI, and China Mobile. But also, I would also like to highlight that AIA in China was our technical partner. So I'd like to give thanks to them as well. Another thank you that I would like to highlight is the Challenge Management Board. So these are seasoned colleagues who has been there during this year, helping us to shape how the challenge can be run. So we hold meetings since the beginning around April, May, up to October, somewhere there, October, November. They have been there every month attending meetings and helping us to shape how we can handle this challenge. And also, I would like to give a thank you to judges panel. This was composed of 16 persons that helped to evaluate the solutions. And from their evaluation today, we will be awarding best solutions. And a small highlight to certificates that we are going to give, as already we have the gold champion, silver champion, bronze champion. On top of these awards, we have 1,000 Swiss francs for runners up. We are going to have a public vote. So this is the best team voted by the public. And we are going to have honorable mention. We have mentors encouragement award certificate, but it's just a certificate, no monetary prize there. And as already highlighted by the director of TSB, we have a special issue and call for papers. So please submit your solutions and join us on Slack for all updates. And please do join us in 2022. Thank you so much, and over to you, Reinhard.
Thank you, Thomas. And now we come to the highlight of today's episode. So we have the 13 top teams, the 13 best teams, going to present for 3 minutes their solutions. And we're trying to do this with Swiss precision. So 3 minutes, and afterwards I will ask you to stop. The order in which we do it is random. So, and also depending on the time zone a little bit. So let's go. We start with the first team, which is the sixth sense. Do we have the sense ready? Can you share? And then I will start the timer. Timer is running. Thank you.
Yeah, so hello, I am Shubham Kudeta from Samsung India. I'm going to present the solution of a wireless artificial intelligence-based location detection problem. My team name is the Sixth Sense. So this problem comes under the technical area, which is integrated sensing and communication, where we do not only do the data transmission and reception, but also we sense the environment also. So in this problem setup, there is a room which is divided into multiple sectors. There is a transmitter and receiver which transmit and receive IEEE 802.11ay packets. So we need to find in this problem, using this received signal, how many persons are present in each sectors. And we also need to find how many people are present in this room. So we need to provide this kind of table as a solution for any example. So the system bandwidth is 60 gigahertz and bandwidth is 1.76 gigahertz and frequency is 60 gigahertz. So usually what happens in conventional method, at the receiver, we do receiver signal processing and estimate the channel first. Then we do range Doppler heat map. And then based on this, we write bunch of rules to detect the presence of the people or the counting of the people. But writing those rules as a detector is really a non-trivial task. So we use ML-based detector here, which will find those rules. But using for ML, we are not using the raw data as input. We use this, we derive some sensible features. And how we derive the sensible feature, the main goal to derive those sensible features is to discriminate these persons as far as possible. So what we do, we first estimate the channel, which will discriminate these people based on the time of arrival of the rays. So there may be possibility of some persons may fall under the same channel type. So we further discriminate them based on the Doppler domain channel estimation, which will discriminate further based on the velocity of these humans. So there may be cases where some 2 or more people fall under the same channel type and the Doppler domain. So we further discriminate these people based on the angular domain channel, where we can resolve them based on their angular position. So the resolution for this, when we do this processing, the resolution comes for the range is 17 centimeter, for the velocity 2 centimeter per second, and we can resolve 2 persons which are 30 degrees apart. So at the final step, we use this ML model of dense layer and ReLU activation. We count the total number of persons using the counting model. We also find the number of persons in each sector using a localization model. So if we see the accuracy of these 2 models, the counting model gives us very good accuracy for SNR 18 and 0. And similarly for the localization model also gives us very good accuracy for SNR 18 and 0 dB. But for minus 18 dB, where the signal is 100 times weaker than the noise, we can't really do much, and the accuracy falls really bad.
3 minutes. 3 minutes are up. Can you finish?
So, yeah, so the novelty of this solution is to use and drive those sensing features for integrated communication and sensing system. Thank you very much.
Okay. Thank you very much. That was team number 1. If you have questions, I would like the audience to put their questions in writing, and I would like to ask the teams to respond in writing. please submit your questions if you have any to the teams that are going to present, and they will respond in writing to your questions. And as I mentioned earlier, after these 13 presentations, we do a public poll for the best solution as determined by the public. So stay tuned. We'll show you how to do this at the end. So now we come to team number 2, which is Team Ember. Are you there? Yes, you are.
Hi.
Hi. If you go to,
Can you hear me? Okay.
Yes, we can. And if you go to presentation mode, I'll start the clock.
So I make a poster for my presentation. Hello, everybody. I'm Team Ember. So I'm gonna presenting the method we are using to solve NAC anomaly detection problems. Network error detection is a critical part for telecom company operations. Hundreds of thousands of devices can produce a large amount of log data. The protection problems can be detected using this data. However, the log data is often not can be automatically processed, and the traditional method of manually checking is inefficient and costly. Thus, we need to analyze log data gathered from network equipments and detect anomaly using AI techniques. Our team proposed a novel method of detecting network anomaly using automatic log data analysis by converting unstructured log data into uniform natural language sequence. Furthermore, we designed and trained an AI model to detect anomaly accurately and efficiently. Comparing to traditional detection methods, our method achieved about 20 to 30% greater accuracy. And comparing to manual method, our method can greatly reduce human error and time investment, thus help company to build a more robust system and reduce operation and maintenance cost. So here's my, this is my presentation. Thank you, everybody.
Thank you very much. Wow, that was, you get an award for the shortest presentation. Thank you, Team Ember. And now we go to the next team, which is Team ML Grads. Maybe I'll just point out the 2 teams afterwards will be Data Explorers and Veronica so that they can get ready. But now we have Team ML Grads. Are you there? Yes, you are.
Hi.
Okay,
Yeah.
great.
Are you able to see my presentation?
Yes, we are. And if you go to presentation mode, I will start the clock. Good, perfect.
Yeah. Hello, everyone. This is Team ML Grades presenting before you the solution for radio link failure prediction. So the background of this problem is that radio links get affected due to bad weather conditions like rain, cloud, etc., which disrupts the line of sight of communication. So this problem statement was mainly to figure out if there could be a correlation between radio link failure and the bad weather conditions and terrain features and RL KPIs features. So the data set presented to us was from Turkcell, was from the real world scenario, which was quite challenging with respect to the fact that there was no single source of truth. We had uneven data samples from different sources and heavily imbalanced data with 0.06% of true label. So moving on to our solution highlights. So I'm going to show here the key highlights of our solution. First is modular design. So the solution incorporates automatic pipeline for training multiple models and deriving the best model for evaluation. So due to this, we see a potentially high possibility of reusing this solution for multiple other telcos with minor tweaks. Then our solution also incorporates intuitive data imputation by following threefold approach using logical reasoning, then random forest model based for imputing categorical features, and KNN for imputing numerical features. The third aspect being multi-tier data sampling. The first level of sampling was done by removing the outliers based on Mahalanobis distance. Then the samples which were received after that was further sampled using SMOT with a combination of over and under sampling. Then further, the fourth aspect of our model is it achieves optimal training time. And this was achieved by using tree-based algorithm and tuning the model with optimal and normalized data sets. So this was the best result which we got with an F1 score of 99.74 and accuracy of 99.7 with a model extra tree. So our conclusion from this whole exercise is, yes, we can predict RL failure with good reliability using the weather conditions, RL KPI metrics, and terrain characteristics. We do recommend that frequent retraining with all and new RL failure scenarios will improve the model performance. Further to it, RL prediction will augment the self-healing capability of networks by enabling them to take further actions for preventing the service interruption and degradation. Thank you. That's all from our side. Thank you.
Thank you very much, Team ML Grant. Perfect timing. And now we move to the team Data Explorers. Data Explorers, are you ready?
Hi, yes.
Okay. Will you share the presentation?
Yes. Can you see my screen?
No. Can we try again? We don't yet see the screen. So let's give you a little bit more time. Otherwise, we go to the next team, and then in the meantime, you figure out what the issue is.
Okay, I have to rejoin because it's for the security reasons I can't.
Okay, okay, no problem.
Okay.
So we go to the next team, and then we come back to you. Okay. So the next team is Team Aronica. Aronica, are you ready? Hello, Aronica. No. Okay, here we have Veronica. Yes. Can you hear me? We don't hear you. Okay, now we see. And if you turn on the audio. Team Veronica, are you hearing this? Okay. Okay, let's see whether we can get this fixed. Team Veronica, can you? Okay, let's try that again. Yes.
Can you hear me now? I think. Can you hear me now?
Yes, now we can hear you.
Okay.
We don't see the slide yet. Can you share the slide set?
I was getting really
double click.
So yeah, I am sharing my screen, and Zoom is telling me that I'm sharing my screen. I don't know if are you reading it or?
Somehow it says here, double click to enter full screen mode. That's all what I see, and that you have. Okay, now we can see it. Okay, now it's up there. Good. Let's see. The audio quality is a little bit bumpy, but let's try.
Can you switch? It seems that my upload is not really good. I'm trying to switch my internet, if that's all right.
Okay.
So should I start now or Team Data Explorers?
Just 1 second. So Team Aronica, what were you suggesting that
I think he's switching the connection, so maybe we can go to Data Explorers first.
Good. All right. So we go back to the original order. Let's try that. Data Explorers, are you ready? Okay, good. That seems to be working.
Okay, can you see my screen now?
Yes, perfect. All right. Yeah, please.
Okay. Hi, good afternoon, everyone. My name is Bayan. I'm presenting the work of my team, Data Explorers. We're a group of 4 working at Ericsson from Saudi Arabia. So the massive MIMO is one of the key enablers for the 5G networks, and it can improve the 5G wireless networks by focusing the energy towards the unwanted the wanted directions and specific users, as you can see in this picture, which will eventually improve the SINR and increase the system capacity. However, these systems are inherently complex due to the high signal processing demands, which eventually limits the performance in practice. Here comes the role of the AI. So the AI-based scheduling and beamforming model is needed to overcome these challenges and meet the potentials of the MIMO systems. So the challenge in this problem is based on simulations of the communication system immersed in VR. And our goal is to schedule and allocate the resources to 3 types of users: the UAVs, the cars, and the pedestrians. And by resources, we mean which beams serving which users, and the radio resources, the channels, etc. Fortunately, this approach of utilizing the virtual world in training, the AI model has been adopted not only by the academia. As you can see here, Ericsson recently has announced collaborations with NVIDIA, where they work on the collaborative project to virtually simulate the radio networks and capture the RF transmissions components to deliver predictive accuracy. So this kind of simulations will eventually accelerate the development of 5G related technologies. So for our RL model, the model is consisted of 3 main sets: the observation space, which includes location, throughput, and the selected UAs. And this set of observations will impact the agent's decision to implement certain actions. Now, the agent is deployed at the base stations, and it will implement those actions in the environments and receive a reward based on certain function, in addition to the previous observation space. This will happen for each episode, and maximum rewards will give when the UAs is assigned to the best beams. Now, the main advantages of RL adoptions in the resource allocations is reducing the processing times for the beam selections. So instead of performing beam sweeping for the 64 by 64 antenna elements to find the best beam to serve certain UE, the RL agents will be trained to the environments and achieve this with reduced latencies. Additionally, the spectral efficiency will improve by utilizing more resources and optimize the beam assignments
Time, please.
to the UEs.
Time, please, if you can finish.
Yes, yeah, that's it. And the user experience will be improved due to these 2 factors.
Okay, thank you, Team Data Explorers. We go to Team Aronica. Let's try that again. If you stop sharing, Team Data Explorers. Good. And can we try Aronica?
Hi, can you hear me all right now?
Yes, we can hear you very well now. Good.
Okay, great. Okay.
Okay.
Thanks for having us here. My name is Mohammad Chegini, and I'm pleased to present our work on fast modulation classification using artificial intelligence. Our team's name is Aronica, and team members are myself, affiliate to Shahid Beheshti University of Iran, and Pooya Shiri and Amira Libani Azadi to University of Victoria from Canada. As you know, AI is really has been used in AI ever since 2-3 years ago, and it's got some advantages and some disadvantages. One of the main advantages is that it is highly accurate. However, that comes at a cost, which is the main disadvantage. Advantage, which is that neural networks are generally really resource hungry. To this end, we propose AaronNet, which is an innovative AI solution, and it is specialized for RF applications. The key point is that our model, the AaronNet, discards unnecessary computation. Therefore, it is very resource efficient, it is accurate, as well as being fast. To explore the advantages of our proposed solution, we provided AaronNet with some signals, some RF signals, and then our proposed solution classified it into different categories of signals. And our solution requires 64 times fewer parameters with respect to the baseline. It is doing this challenging task with only 3,000 parameters. And as I stated, it's got a competitive accuracy with respect to the state of the art. And AaronNet is a family of solutions. By tuning some parameters, you can have a great deal of control over the model. So if being resource efficient is your goal, you can have that. If being accurate is your goal, you can have that. But both of them are resource hungry and have a high accuracy. So depending on your need, you may choose any of them. Thanks for having us here. And yeah, any questions, I'd be happy to take them.
Okay, thanks very much, Team Aronica. So if the audience would like to ask questions to any of the teams, please put it in writing, and then they will respond in writing. Now we come to a team, how do I pronounce this? SOF, SOF GNN. And let me just announce afterwards, we have Team Orion and the Digi Pioneer. So now we have Team SOF GNN.
Do you see my screen?
Yes, we do.
Okay, so let me present the results of the SOF.
Can you go to presentation mode? And,
sorry.
Yeah, if you.
Oh, okay, sorry. I thought it was.
No worries. Okay.
Okay, so let me present the results of the SOF GNN team. The project was about the motivation of automated 5G, beyond 5G networks, which are expected to be very complex, however, very flexible and dynamic. So in 5G, as you know, there are different three major classes of traffic. And the goal of the challenge was to focus on the ultra reliable low latency class traffic with the predictions of the latency or the delay. So considering the size of the networks and the volume of the traffic, the only way to manage or to succeed in predicting KPI is to use machine learning. And that's what we did with the improvement of graph neural networks performance through the design of scale-independent features and scale-independent output. That was our motivation in the improvement. So the key ideas, we reuse the RouteNet design. However, we design our own graph neural network architectures, our own message passing scheme, and we address the out-of-distribution data with some feature design and out-of-distribution output with output transformation. So for the feature design, the idea or the key ideas was to use relative rather than absolute value. That's what we did with the link load, using the usage expressed in percentage rather than the capacity of the link. For the output transformation, same ideas, although it was to use the queue occupancy as a predicted value. And from there, we deduced the delay. And again, queue occupancy was computed as a relative value rather than an absolute value.
1 minute.
neural networks, we design a new architectures and summary of the results. So we started from the result of the previous competitions where the accuracy was 300%, going down to 1.3%. And in terms of the delays, we takes only 1.3 seconds to compute the delay. And in terms of training, it's still few hours, but still much less than what we heard from the solution of the other teams. So that at the end, we can reduce the energy consumptions using our program. That's it.
Thank you very much, teams of GNN, for that. And now we move to Team Orion, and afterwards we have Team Digi Pioneer. So Team Orion, are you there?
Yeah.
Okay.
I have shared my screen as well. Is it visible?
Yeah, and if you go to presentation mode, then it's perfect.
Just give me a moment. Yeah, hope it's visible in presentation mode.
Yes.
Okay, just give me a moment as well.
Yeah, no problem.
Yeah. Okay. Hi everyone. I'm Sai Krishna. I'm here to present our solution for RF-based human activity recognition, which we have solved using hierarchical classifier here. We are a team of 4 members from Beyond 5G team of Samsung R&D Institute, Bangalore, India. Yeah, why RF sensors? Like it has advantages over most commonly used sensors for activity recognition, such as camera, especially under low or no light scenarios. But how we do it, we get the raw data from RF sensors and then we do some pre-processing. And then we take short-time Fourier transform to get a microdoppler spectrogram. Now for each of the activity, the spectrogram will have a different pattern. So we use a classifier, an ML or DL based classifier to detect what activity it is. Here you can just see the different kind of patterns for the 11 different activities which we need to classify according to the problem statement. Then we started with having a single unified network, but then found, okay, the confusions amongst few classes were quite high. And then we visually again observed like what are these classes, and we found the classes to be pretty similar. So then we moved on to hierarchical classifier, wherein we merged classes which were pretty similar together to have a first stage classifier and then have a more detailed classifier to subclassify amongst those confusing classes. So if you can see while deploying, suppose you don't know what is the class that the given spectrogram belongs to, then you pass it to the first stage classifier, then get the outputs. If they belong to any of the merged classes that we are trained a priori, then we employ the second stage classifier again to finally come up with what is the required activity that is being performed that the ML solution needs to detect. Now, the major thing is here, okay, we have mentioned various classifiers. So we employed an inception-based network for all these classifiers, but the new point here is like we went for rectangular kernels rather than square kernels, which are prevalent in the existing literature. This helps in a bit to get the more appropriate features with less complexity. Also, as we have seen through, the confusion also is reduced based on this hierarchical classification along with complexity reduction. Detailed architectures can be seen in the presentations that we made before 2 weeks prior, for which the links were provided in the chat by Thomas. The results here, you can observe like the problem organizers have published a paper on the same activity in 2020. We took those baselines and then we compared that with our present architecture, and we found an improvement of around 4 to 5% across a different kind of RF sensors in terms of accuracy. At the same time, having less compute required. That is, we reduced the complexity by around 7% compared to one of the architectures named CNN, and reduced our complexity by around 53% compared to CIE to the existing baseline solution that the organizers have provided.
Okay.
That's it from my side. Thank you.
Thanks very much, Team Orion. We move to Team Digi Pioneer. After Digi Pioneer, we will have SSN ITU and Team Piranha. So let's first go to Digi Pioneer. Yes, we can see your presentation. Perfect. If you also go to presentation mode. Yes, thank you.
The competition that we participated in is 4G, 5G cell traffic KPI forecasting. That is, we needed to forecast 12 KPI or traffic indicators of 4G and 5G cells based on 6 months of historical data with some additional cell parameter data provided. The original data is about is more than 200 gigabytes in total, and we needed to perform the forecasting with relatively limited hardware resources, and the scoring rule was MAP, which can be sensitive when the true value is small. So our final solution is based on MLP, that is a neural network model with some additional skip connections added with normal fully connected layers of MLP. First, the original data is pre-processed into time series data and then into tabular data for training the model that forecasts future values with historical values. So with the latest part of historical indicator values, the model can produce a final forecasting result. The prediction is relatively accurate. That is, the MAP score is better than the other teams. Also, it takes 4 hours for training and 2 minutes for inference with pre-processed data, which is a small time compared to the large amount of data provided, that is about 200 gigabytes from 67,000 cells. The model can be adapted to any scenario by adjusting the complexity of network and some other parameters. Our model has been integrated into our network energy saving system and applied in Jiangsu province. Our proposal for the system has also been approved by ITU. In the future, the model can be applied by, for example, by an AI platform or facial info and be used by multiple network optimization systems and serve different network AI use cases, which all involve some kind of forecasting of traffic KPIs. Thank you.
Thank you. That was team Digi Pioneer. Thank you very much. And we come to team SSN ITU.
Hello.
Yes, hello.
Yes, I'll share my screen right now.
Okay, thank you.
Am I audible?
It's coming. Yes, perfect. Floor is yours.
Hi, everyone. We are team SSN ITU. Our problem statement is location estimation using RSSI of wireless LAN. So when we talk about location estimation, the first thing we think about is GPS systems. But in indoor environments, we find that the GPS systems give highly inaccurate values due to attenuation of GPS signal. So thus, we can use a receive signal strength, which is a feature of a wireless LAN network. Now, traditionally, RSSI has been modeled, but this does not include all the fluctuations that are present in the RSSI in real time. And hence, we have proposed an AI/ML-aided localization model that utilizes RSSI to find the location. Now, let me explain how exactly the model works. So if we have 4 access points and we have an unknown node, it receives RSSI data from all 4 access points, as we can see right now. So it receives from all 4 access points. And the relationship that we have exploited is the relationship between the RSSI value and the distance between the receiver and the transmitter. So if you can see in the diagram, the green points denote that there is a high amount of RSSI value. The RSSI value is high, and the red denotes that the RSSI value is low. So as we can see, as the distance increases, the RSSI value reduces. So this is a principle that we have used in order to find the location of the unknown. Now, the proposed working model is as follows. So the RSSI values that I have shown before from all the access points of the APs are given to the model, after which the data is first pre-processed using multiple pre-processing techniques like smoothing, feature selection, and data augmentation, which are all optimized. And then it is given to the regressor model. the output of the regression model is the location of the unknown node, which is the latitude and the longitude of the unknown node. Now, let me state a few of the advantages of our model. We have multiple advantages, and a few things that are worth mentioning is that our latency is 0.173 milliseconds, which is the time between receiving the RSS signals and predicting the location is very fast, and so it only has a latency of 0.173 seconds. It is an AI-based techniques, and hence it's highly reliable and has very good accuracy in indoor systems compared to GPS. Now, to state a few of the uniqueness of our model was trained using very less data points. So in real-time environment, when we want to deploy the model, the time taken for training our model is very less, and we need very little resources to train our model. We have the real-time RSSI values are also highly dynamic, and our model can accommodate all of this dynamicity of the RSSI, as you can see in the graph below. Now, generally and theoretically and in multiple papers, we have seen that the location that is predicted of the unknown nodes are generally inside the physical area of the covered by the APs, as you can see. But our model can also predict the location of the unknown nodes, which are outside the physical area covered by the wireless access points. Now, coming to the wide range of applications that our model can be used in, is that our model is a positioning system. So we can use it to monitor and analyze the flow and movement of people in multiple scenarios, like in airports, railways, even in shops. So giving a small example of it is that in shopping carts, in shopping malls and things like that, we can monitor the flow of people and restock items and position all the stock items depending upon this. Coming to the actual technicalities of the model.
Time is up. Can you finish in 10 seconds?
Yes. Yeah, so we have validated the model using the data set that was provided to us, and we have gotten an average error of 4 meters, and we have gotten latency as seen before at 0.173 milliseconds. So our model can be used as both an indoor positioning system, outdoor positioning system, and also along with GPS to give a good positioning system. Thank you.
Thank you. Thank you, team SSN ITU.
Thank you.
We move to the next team. We have 4 teams still in the queue. So the next one is Team Piranha. Then we have Team Automata, Team Federation S, and Team Bacalhau.net. So Team Piranha.
Right. So can you hear me?
Yes, we can.
Okay. Let me move on to the slideshow. You can see it clearly as well.
Yes, perfect.
Okay, let's go. Hello, I'm Bruno Klaus, currently a PhD candidate at the Federal University of São Paulo, Brazil, a sole member of Team Piranha, and today I'm going to be talking about the first place solution of the graph neural networking challenge. So the problem was the problem of generalizing to larger 5G networks. The goal was to achieve production-ready graph neural network-based solutions. So we want to train models in network testbeds of limited size, but still be able to directly operate in larger, real customer networks. So in this challenge, we train on small networks of at most 50 nodes, and then we must scale to larger networks of up to 300 nodes. And those networks may have longer paths or higher link capacities. So there are a few possible approaches to predicting network delay. The analytical approach uses queuing theory, and because of that strong theoretical foundation, it is fast enough. It can generalize to larger graphs as well, but it does not have top-tier performance. It's more of an approximation, really. Aside from that, you have packet simulators. They are pretty good, but they are just too slow to be considered in this challenge, so they were not allowed to be used. Then we have RootNet, which is the previous graph neural network-based approach. It is fast enough. It does have top-tier performance, unless you try to generalize to larger graphs, in which case it goes from something like 1 to 2 mean absolute % error to over 300. So our proposed solution, it is fast enough. It does have top-tier performance, and it generalizes to larger graphs. And we achieve this by first we read raw link and path features. From there, we can calculate robust features using a queuing theory baseline. And then we use the modified RootNet to get the fine-tuned prediction. So here are the results. We had two models, Model 1 and Model 2. For Model 1, we wanted to make it as big as possible to get the best result. In the end, we figured out that it wasn't really necessary at all. This Model 2 right here, it's way smaller than RootNet, and it still achieves exactly the same result as Model 1 on the test set. And each of them was a little bit better on a given validation set, and we can take the simple uninformed average and get a little bit of a boost. Aside from that, the baseline also gets a really respectable score of around 10 mean absolute % error on the test set. On the other hand, if we remove the queuing theory features, we only get 22.58 mean absolute % error. So we can see that using those queuing theory features were absolutely crucial. And if you look at the leaderboards after 4th or 5th place or so, everyone really struggled trying to make a generalized out of distribution. So using the baseline makes a huge difference. And using that, we achieved the first place. Our approach also trains and converges in like 1 hour or something. And those are the training curves. They converge relatively fast. All right, that is it. Thank you very much.
Thank you very much. Perfect timing. That was team Piranha. We move to team Automata. Yes, very good. Team Automata.
Yes. Can you hear me and can you see my slides?
Yes, we can hear you. And if you go to presentation,
great, thanks.
Thank you.
Okay, so this is team Automator. So I'm starting my presentation. And the problem we tackle in this challenge is that in case of an emergency, for example, earthquake or fire, so we want to develop a solution for autonomous resource allocation for emergency case and emergency network slices. So we also want to support other existing network slices in the system properly. So we take this problem in an open RAN context and we get high-level information from non-real-time RIG platform, and then it triggers us to operate at real-time RIG platform, and we are at real-time RIG platform. So details are as follows. The first, we get the high-level intent from the non-real-time RIG. We parse it, and this intent includes some information. For example, where the information about the emergency case, for example, where the data and ML models are, and also it indicates that there is an emergency case. So then we start our traffic forecasting building block, and we start to predict the future traffic for all the network slices in the network. So here, to understand how much resources we can allocate the emergency case. So here, for traffic forecasting, we use Gaussian process regression, and for time series traffic forecasting. And then we decide on the level of the priority on emergency case. So we have developed two algorithms. The first algorithm gives priority to existing slices, but the second algorithm always favors the emergency case. And then our resource allocation building block starts, and depending on the selected algorithm, it decides on how many PRBs, the resources, the physical resource block resources, we should allocate to emergency slices. Here we utilize the predicted traffic, and we turn this resource allocation problem into an integer linear programming. Then we solve it to find the required PRBs. So for example, here, if the emergency case needs 20 PRBs exactly, so we take 11 or 12 PRBs from the first slice and 8 or 9 PRBs from the second slice. So in total, we always give 20 PRBs to the emergency case. In our last building blocks, we keep, so it behaves like an server, so we keep different ML models. So this gives us some flexibility to select different ML models depending on their complexity, cost, and the performance. And for proof of complexity implementation, traffic forecasting blocks and the resource allocation blocks, they are implemented as RIG-XApp, so they can communicate to each other with a messaging protocol. And our last building blocks, it is implemented as a web server. So the traffic forecasting XApp, it sends predicted traffic to the second XApp.
15 seconds.
And okay, it gives the decision, and traffic forecasting, it fetch different ML models depending on the performance on the other criteria. This is our solution. Thanks.
Thank you very much, Team Automata. Now we come to the team Federation S. Federation S is next, and then the team will be Bacalhau.net, Federation S.
Hi, can you see my screen?
Yeah, perfect.
Okay. Hello everyone, I'm Jan and I'll present how can federated learning be used to improve your Wi-Fi experience. So if you ever try to use Wi-Fi in a crowded space, you might have noticed that it slows down, a problem that we in telecommunication community pay a lot of attention to. And we do it by making amendments to the standard itself. And with each amendment, we add more parameters that our router needs to select. And selecting these parameters that will result in the best performance for the user is a very complicated task, and machine learning is a perfect example how we can use it. But if we want to deploy AI, we need to actually start collecting data. So there's a certain trade-off. Either we preserve user privacy that will lead to lower performance, or we collect data to improve the speed. Luckily, we can use federated learning that can accomplish both. And this was the focus of this challenge. We studied the use of federated learning to select the optimal threshold and improve the Wi-Fi speed, but avoiding data. So underlining assumption here was that if we can predict the best performance based on the threshold, we know what settings should your router have. And with federated learning, we perform training a neural network locally. And then only the neural network, not the data, is transferred to the central server where neural networks from multiple stations, so multiple routers, are then merge. And the central server federates, meaning that he selects who's going to perform training, and then we perform training in each training step. And this is where we also get this name federated learning. In terms of our solution, we first focus on analyzing the data that the Wi-Fi station realistically has access to. And then we analyze certain correlation between the patterns, which ultimately led to design of our neural network. And the unique part of it is that we have two separate inputs that are then merged further inside, deeper inside the neural network. And once we establish our neural network, we could move on to the training process itself. So as you can see, as we train, the error, so the error of our prediction goes down for both validation and the training set. As you can see, the downform performance. In terms of how our solution performed to others, our solution achieves similar throughput performance to a centralized learning approach would have, while also improving privacy and security. While on the other hand, our approaches may preserve privacy and security, but then they will suffer in terms of performance. So I would like to thank you for your attention. And if you have any questions, please get in touch with us.
Thank you very much, Team Federation S. And now we come to the last team, which will present today, and that is Team Bacalhau.net.
Yep. So,
okay, thank you.
You can see everything.
Yes, perfect.
So hello everyone, and thank you for being here. I am presenting Bacalhau.net, a tiny CNN for lightning fast modulation classification. The team was composed by José Rosa, Daniel Grinhão, Tiago Gonçalves, and I, Guilherme Carvalho. So it is undeniable that there is a need for improved radio efficiency. One way that it can be achieved is through adaptive spectrum sensing techniques. So the principle is simple. If the transceiver can select an occupied channel, efficiency is improved. This, however, requires fast modulation techniques on the receiver end. And so deep learning has proved to be very robust at pattern recognition tasks, but it has the obvious downside of being computationally expensive. So what if we can make deep learning less resource intensive? So our challenge was to design a deep neural network capable of achieving at least 56% accuracy on the radio ML 2018 dataset at the minimum cost possible. So then we present our solution, Bacalhau.net. It is a tiny convolutional neural network featuring commonly used structures. In the end, we settled for a model with 59% accuracy and cost scores after quantizing to 8 bits of 0.146. This network was at this point 6.85 times cheaper than the baseline VGG. The network was then further compressed using quantization and pruning techniques. Activations and weights were quantized both to 6 bits, and several iterations of unstructured pruning also followed. The network achieved a remarkable compression of 61.73 times smaller than the baseline, while keeping the intended 56% accuracy. So to conclude, we feel that our network is then more than capable of responding to the needs of automatic modulation classification. We also hope that solutions like the one that we are presenting here today help develop a more sustainable future by creating solutions with high throughput that are able to be implemented in resource-constrained devices, thus reducing energy footprint significantly. Thank you very much.
Thank you very much, Team Bacalhaunet. So these were the 13 top teams out of the 32 best teams which presented a couple of weeks ago over a 3-day session. So now we will start the public poll. And my colleagues will display a slide to show how we do that. So please go to this website. The website is pigeonhole.at/ML5G. And then you will see all 13 teams displayed that presented just now. You can also see the link, the URL in the chat. So we'll give you about 3 minutes. Pick your favorite team out of those 13 teams that have presented just now. The winner will be awarded with a certificate and will get a cash prize of 500 Swiss francs. So while you're picking your favorite team, let me just tell you what's coming up next. So we will hear a couple of voices from our hosts of the 2021 challenge. So hosts for the entities which provided problem statements for this year. So we will have José Zores Varela from Barcelona Neural Networks take the floor, Michaela Blott from Xilinx, Zhang Cheng from AIIA in China, and Aldebaro Clautau from Brazil. And following that, we will have our colleague Vishnu give an outlook of the 2022 challenge. Then we will have an exciting keynote by Kees Wissers from Xilinx called The Role of AI in Future Communications. So Kees will be getting up very early on the West Coast of the US in order to deliver this talk. So that should be very exciting. And then we will come to the award announcements. So we will still have a little bit of time to let you fill out the poll. I didn't start my clock, so I'm not sure how much time we already spent on that. Okay. I don't know, Bastian, do you see how many people have already voted? Do you have a feel for whether we could close it? Or we just give it a little bit more time?
We got 200 and something votes, 211.
Oh, okay. All right. Let's give it maybe another 30 seconds, and then we finish the public poll, which will determine who the public thinks was their favorite team, their favorite presentation, their favorite team. Good. So let us close that. Let me maybe first check whether, Jose, are you there?
Hello. Yes.
You are there. Okay, good. Yeah. So before we'll get to you in a second. So Bastian, if we close the public poll, I think we have enough votes to speak, and then we will announce the winner of the public poll also during our award ceremony. Okay, so thanks very much, Jose, for joining. You were also a host of a problem statement last year. You had a very exciting problem statement this year. You have this year. Can you maybe say us something? How does this year compare to last year's experience?
Okay, so hello all. This is Jose Suarez Varela, and I'm a postdoctoral researcher at the Barcelona Neural Networking Center in Spain. I'm also part of the organizing team of the Graph Neural Networking Problem. So after a second edition, I can say that this competition has been a very worthwhile experience that has attracted a lot of interest, both from members of the networking community, but also we have seen a lot of interest from the machine learning field. So in this context, I would like to congratulate all the participants, as you all have shown a great motivation on the different problem statements. Indeed, during the presentations of the Grand Challenge finale, we have seen many outstanding solutions. So for example, in the graph neural networking problem, some solutions were even beyond the state of the art, which at least for me was quite impressive. Well, I think that in general, to address the challenges of next generation networks, we'll need more experts in networking and AI. And that's why I believe that this initiative will have a large impact, not only nowadays, but also in the long term. As it is a very good format to introduce new students, researchers, and professionals to the field of network AI. And also, I think that nowadays a main barrier we have in network AI is the lack of public datasets. And in this context, this competition is an extraordinary opportunity to gather these kind of datasets and open source solutions, which are fundamental to advance the research in this area. So to wrap up, I would like to say that it has been an absolute pleasure for me to host a competition here for the second time. And I would like to thank especially Thomas Basicolo, Vishnu Ram, and Ryan Skoll from the ITU for pushing this great initiative for the second year and for their great talent to convert it in such a great event. So thank you very much. I strongly believe you have done a great job again, and I'm really looking forward to seeing all of you in a new edition for the next year.
Wow, fantastic, Jose. Yeah, thanks a lot. If you are ready to get on board for next year's challenge, that would be fantastic. Thank you. Good. So we go to Michaela. So Michaela from Xilinx. Hi, Michaela. Xilinx was not only a sponsor of this year's challenge, but also the host of a problem statement. You had provided a fantastic sandbox and really a great environment for the teams to compete for your problem statements. So what's your resume of this year's challenge?
Okay, hi everybody. So we in Xilinx believe that machine learning and communications, and in particular in 5G, is only just starting and a super important field of research for many opportunities, in particular with regards to our Xilinx FPGA devices. As such, we were delighted to be involved in this year's ITU effort in this space, and we believe the ITU is doing a fantastic job here to drive the research and building a community around the subject. So as Reinhard mentioned, we posted the lightning fast modulation classification problem statement. It was our first time and hopefully the first of many to come. And the gratitude for the sandbox does really go to my co-organizers, Alessandro Pavalado and Yamano Muboglu, who both are on the call. They did a super effort on actually preparing the whole challenge. So we were really impressed with the level of participation that we've seen and the quality of the submissions despite the ongoing pandemic. I mean, 61x over our original baseline, it's fantastic. So massive thank you to all participants for the time and effort, and in particular, congratulations again to our top entries. Secondly, I'd like to say on behalf of all of us here in Xilinx, massive thank you to the ITU for involving us, and in particular to Thomas, Vishnu, and Reinhard, and she's up. I mean, you've been all such a pleasure to work with, and we think you've done a fantastic job organizing this whole grand challenge and putting this together. And finally, I would just say best of luck to all the finalists with the grand finale, and thank you again to all the participants for their amazing efforts.
Thank you very much, Michaela, for your nice words. And now let's move to China, to Zhang Cheng from the AIIA, the Artificial Intelligence Industry Association. So we've had a great partnership, not just this year, also last year. So AIIA provided the front end for the challenge, and also has lots of experience in running challenges also in China. So really happy to have partnered, being able to partner with you. So would you like to say a few words, Zhang?
Okay, thank you, Chairman. Can you hear me?
We can hear you. Would you like us to see you, or we can also just hear you? That's fine too.
Okay.
That's okay, all right.
Because I'm in my home.
It's already really late in China. Yes, okay, that's fine. Okay, you'd like to say a few words? Yes, okay.
Yeah.
Good.
Congratulations on the success of ITU AIML in 5G challenge. And also thanks to ITU for overcoming the pandemic and holding this competition. In this competition, we see teams all over the world contributed their great ideas and solutions. This competition is of great significance to promote the convergence of AI and future networks. So AI will continue to support the ITU's AI competition, and look forward to more exciting challenges next year. Thank you.
Okay, great. Thanks very much, Zhang, and thanks for staying up late. So our last intervention will be from Aldevaro Clauto in Brazil. So Aldevaro is also a big supporter of the challenge. You were host of a challenge of a problem statement last year. You're also the leading guest editor of this year's special issue related to the challenge. So Aldevaro, how does this year compare to last year? What's your impression?
Well, I believe that the ITU challenge is just getting better. It's clear that based on the presentations that we saw today, that people are getting really more advanced in terms of algorithms and also the knowledge. And it was great to see the presenters making such a wonderful job and representing very well all the effort from all the teams that participated in this ITU challenge. I believe that on behalf of our team, I should congratulate you, the organizers from ITU and all the participants. And I also believe that we are entering this second generation of artificial intelligence applied to communications for two reasons. The first one, we are departing from experiments with very limited and personal data sets. And the second reason is that now we have AI machine learning standard interfaces, such as the ones that ITU is developing. And then we can actually go and deploy the models in the networks. So basically, we are very excited and looking forward to contribute with the 2022 ITU challenge, and congratulations to all of you. Thank you.
Good, thanks very much, Aldevaro, and also thank you for being the leading guest editor of the special issue of the ITU journal related to the challenge. So we continue in our program. We have now Vishnu going to speak about giving some thoughts on the challenge 2022. And then we have Michaela. I'm looking to see whether Kees is already connected. He will have to get up really early in California, but I don't think I see him yet, but he still has 6 minutes left. So I don't know, maybe Michaela, if you could check.
I will.
whether Kees will be there. Okay, so, but in the meantime, Vishnu, you are a storyteller. You say in your next presentation. So what is your story here?
Thanks, Reinhard. Hello, colleagues. My story is that I have some problem sharing the screen.
Okay. Wow.
So,
all right.
Which is strange. It hasn't happened before, which is really strange. Let me just check once more.
Okay, perhaps we can help.
That will be great. Yes, that will be great also.
Thomas, I can share, or let me see, or Thomas, let me just get this up and then I can share. Let me, yep, okay, coming up. Now let me just get this right here. Okay. I hope I'm sharing the right screen here. Is that visible? No,
Yes, thanks, Reinhard. Yes, thank you.
I don't think I'm sharing the right screen. I think not.
Presentation mode, but
Yeah,
not the full screen.
Because I have two screens. Okay, all right, let's try that again. Share, maybe I'll do the PowerPoint here. That should work, maybe. No, that doesn't go to presentation mode for some reason, but I think you can see the.
Can I share? Can I share in here?
You want to try that? Okay, good.
Yeah.
Try that, Thomas. Thank you.
Thank you, Thomas. Yes. So yeah, this is my job is a little tough. I am trying to predict things. Prediction is less accurate, as you know. It is an outlook for next year, what we think are the stories to come. I am basically putting the hat of a storyteller today. Next slide, please. Okay, so a couple of insights that we got, you already saw it today. First one, what I would like to tell you the story of hidden data. We always get this question. Is the data real or is it simulated? Is test data available? Open data sets, that's always a question when we talk to hosts. And what is the model accuracy? Where is the data ready, etc. But however, I think next year, and we have seen from the last 2 years, is that it's not a question of whether the data is real or not. It's a question of whether it is realistic, whether it is diverse enough, whether it is tested clean, and do they hide a story. We would like to see that story come out, right? As you saw today in the presentations. And we would also like to move from model accuracy to the question that do we really need to produce models always, or are there some other things, some other interesting things to look at? For example, data generation, classification, and such kind of problems. Are the tool sets ready? So if you see, the participants have been always asking in the while loop, right? Whether the data is available, where is the data, where is the data? That's the question that always the participants keep coming back to the host. But we also see that when the data is available, they move to the question where is the tool set? How do I look at it? How do I analyze it? So that brings us to the next slide. We move to the next slide, Thomas. So this is the story of a notebook. In a notebook, we would like to move to the questions of from the data to how to train the model. What is the baseline? From there, we want to move to the question of what is the baseline which I can extend. You heard you heard Michaela, you heard Jose, today, just now, talk about the baseline and how that is extended, right? So we move from the question of how to train the model to what is the baseline which can be extended, whether there is, what is the state-of-the-art benchmark, and how to reproduce beyond that, where is the paper which is available? You heard the participant talk about it. And what are the tool sets? So this is important. You heard Michaela talk about the sandbox. That was a very important initiative from Xilinx this year to open a sandbox for the participants. So if you give the data to the participants, we think that they don't know too much to do with it, except that we give them along with it notebooks, iterative progress, which can be learned and move from winning to learning to make iterative progress using notebooks. Next slide, please. This is the story of host, where we would like to see things going. We think that the host currently provides problem statements, but of course there is a difference between providing problem statements to onboarding the participants, giving webinars, hosting roundtables, providing sandboxes, hand-holding and mentoring the participants. So I think this makes a difference between the conversion rate from registrations to submissions to winning teams. That's what makes a difference. The host also evaluates at the moment, but we want them to move to an automated evaluation scheme like what Jose has, for example. Hosts are also local to a country, but at the same time, we think that the participants are global. You see a lot of participants coming from across the world, right? So we also would like to see webinars in different languages. So here, if you see this figure, we think that we want to provide an ecosystem where there is mentoring, webinars, notebooks, and follow-ups and engagements. Next slide, please. This is a curious case of a participant. We have seen many different types of participants. There have been last-minute, sprints. There have been, last-minute work. But at the same, pretty good. I'm not blaming. But at the same time, we would like to move to an iterative progress. The host evaluates, but at the same time, we would like to we would raise the bar to go towards participant providing tested values, self-evaluation, and reports. And instead of submitting solutions, we think that the participants can actually engage with the host a little more. Some stories on the right side, we have seen participants forgetting to register, but having the solution ready. And we have seen hosts wondering, where is the documents and trying to get the documents ready for the participants. Next slide, please. Then, yes, so swiping left or right. So we would like to look at who our partners are in 2022, maybe perhaps a simulation platform. Aldabaro knows exactly what I am talking about. So a simulation platform, for example, gives a rich environment for the participants. And SBO, maybe, ITU is one, but maybe there could be other partners from industry bodies, open source bodies. We are talking to some of them, and maybe perhaps all of them, right? So if you look at the focus areas on the right side, there are many areas in next generation technologies, digital twins, auto ML, location-based. There have been some problem statements this year as well. Semantic communications, AI design, the air interface, IoT, closed loops, and perhaps there is question marks on what we can do otherwise. So it's a question of finding the right partners. Next slide, please. So what is the moral of the story? Moral of the story is that we strive to bring innovations, as Thomas told in the opening. Beginning itself, we try to bring innovations. We look at whether our reports are valuable, whether we are able to build lasting collaborations or not. So the question is, are we really asking searching questions or not? That's the question, right? Next slide, please. So with that, we look at launching our next 2022. Next slide, please. You can join the Slack and look at Yeah. So 2022 edition, we look forward to it. If you all, at my count, press in the screen, launch challenge 3, 2, 1. Nothing is supposed to happen. It's just a joke. I carry forward from last year. There is nothing to happen. We look forward to next year's challenge. Please join us there. Think about the outlook and let us know what you think as well. With that, back to you, Reinhard. Thank you.
Thank you very much, Vishnu, and also a big thank you for being engaged, so engaged in this year's challenge and last year's challenge. Okay, now we come to the keynote, the one and only keynote of today's talk. So we're happy to have Kees Vissers from Xilinx with us. Thank you very much, Kees, for getting up really early.
My pleasure.
California. Well, I'm sure it was a pleasure, but thank you. So Kees has, for 2 decades, he has been heading a team of researchers at Xilinx, including a significant part of the Xilinx European laboratories. The research topics include next-generation programming environments for processors and field programmable gate arrays, high-performance video systems, machine learning applications and architectures, wireless applications, data center applications, and he has also been instrumental in the high-level synthesis technology and adaptive intelligence engines. So you have a very captivating title, a very exciting title. Yes, it's called The Role of AI in Future Communications, and we are looking forward to your crystal ball. Can you share? Would you share? Yes.
Yes.
Okay, good. Perfect. Perfect. Yes.
Okay. Thank you very much for inviting me. I will briefly talk about the exciting opportunities and encourage you to really work in this field to find the right answers. So let's talk a little bit about communication systems. What's going on in communication systems? What's happening moving from 5G to 6G? We're seeing new modulation schemes. We're seeing significantly higher frequencies, which means that your run-of-the-mill cell phones and Wi-Fi that is in the 1 to 3 gigahertz is moving all the way up to 60 gigahertz. And that has all kinds of communication consequences. 60 gigahertz is a very short wavelength, has different attenuation in the air, works essentially with reflections, and is leading to many, many quite compute-intensive algorithms. Massive multiple input, multiple output antennas, beamforming technology. Because of the higher frequency, the antennas get smaller, so it's possible. And it's even going to individual tracking of users and individual cell phones, while in a cell you want to get hundreds to thousands tracked like that. Next is also vehicle-to-vehicle communication, and so this is a very exciting field. Now, why is this so important, and why is it important for AI? Well, previously we could build a static radio system and more or less have a point-to-point communication with something like a cell phone, and we would be done. However, as I've pointed out, this becomes more and more dynamic, which requires continuous adaptation of the system. And that's where the new opportunities come. So let's take a one slide look at what's the classic approach and why is AI so interesting. A base station is basically a connection to the internet, and you have an Ethernet connection, you have a basic front-end packet processing, a baseband processing, including beamforming, and then essentially digital radio, power amplifier, and then analog, and then to the antenna. What you see here is traditionally in signal processing, this is tens to hundreds of teraops compute. Now, you can implement that in many different ways. One of them is you can do conventional servers, but then you will very rapidly run out of total power consumption for data center style solutions. So what is happening next is people are building dedicated chips, ASICs or application-specific processors that contain programmable devices that implement the algorithms that are needed for this kind of communication. And then there's specialized technology, A to D, D to A conversion, power amplifiers, and so on. Now, in conventional signal processing, we address this adaptive part by building adaptive control loops and feedback systems. And that way I can do either static and dynamic tuning. What are deep neural networks? The beauty of deep neural networks is potentially at the expense of significant compute, and we'll get to that in a second. I actually, if I have the right data set, don't really need too much domain expertise. And so neural networks can help you in any transfer function and in any dynamic transfer function. And if you can train it, in the end, you can have neural networks penetrate many, many different domains. And several ones we talked about is in the communication space, and I'll touch on what the challenge is there in particular. But you can also tackle new problems, and many publications in Nature are alluding to the opportunities. What's the problem with communications and machine learning and deep neural networks? Well, the problem is that I basically have very high communication speeds. I have low latency and high compute requirements. So I want to run in the communication chain at hundreds of mega samples per second throughput. And so this is not your image recognition at 50 frames a second. No, this is complete communication standards in hundreds of millions of iterations a second, and then preferably in low latency. Let me give you two short examples. So what is digital predistortion? Digital predistortion is I have a power amplifier, and this power amplifier is driven in the nonlinear domain. So I usually give it so much input power that the output power is not linear anymore. And if I now, with the right level and figure out at what point in the curve I'm operating, pre-distorted in the opposite direction, I actually can have it behave as a linear power amplifier with a feedback loop. Traditional signal processing can be used. And what is currently deployed in industry is many adaptive filters, feedback loops, particular smarts on the control processing, most of the time with processors, and a very high speed forward multiple filters with adaptive coefficients. Now, this problem can also be tackled with machine learning, and you would replace the whole box with an inference and try to train that. And it's a very interesting topic, and I would encourage you to think deeply on what the pros and cons are, and potentially even think of it as, can I deploy this in the field, and is this doing in the field what I thought it would be doing? Another topic that Michaela and team have alluded to today is the classification question. Given a number of signals coming in, what modulation is used, and the data set, as already mentioned before, is the name of the game here. So if I have the right data set and I have the right questions, then I can try to tackle this with machine learning based approaches. The problem is that this machine learning has been posing an enormous compute load much faster than conventional increase in what is called Moore's law will buy you in just better silicon and better implementations. So now you need to do something, and there's two possibilities. One, you can deploy the same technology, but then lots and lots of it, or 2, given the characteristics of neural networks, maybe I can build dedicated hardware that is more efficient and better at this particular compute that will close this gap. And we'll talk about that in a second. We already seen that to implement neural networks and not only experiment with them, which ones are the good ones, but really the impact in communication will happen if I can implement neural networks in the system of the communication system. I basically need hardware that can implement neural network primitives. It needs to be programmable. It needs to be trainable with the frameworks like TensorFlow or PyTorch. And in particular, for the communication domain, I need low latency and very high throughput. So let's talk about this. Will servers do this? The answer is servers can do this compute, but as I've shown you, the workload and the compute load that you need is hundreds of teraops, and that's not necessarily a low power solution with CPUs. Can I do this with GPUs, the standard successful technology in this domain? Maybe, but as we know, GPUs are really good and really efficient if I can get high level of batching, and that is actually in competition with low latency. Can I do this with dedicated ASICs? I basically fix the network and I build one network in an ASIC. The answer is you can do that. However, we don't know what the real network is in the long run, so I want programmable networks. And so what you see emerging is all kinds of technology that is application specific, that contains dedicated programmable IP blocks, mostly processor-like, that are capable of doing efficient neural network implementations. I'll talk a little bit about what you can do with FPGAs, can talk a little bit about what you can do with specialized multicore. I'll go fast. FPGAs, Michaela has explained this in the past, is a programmable bit-oriented logic with embedded memories and embedded first-order multiply accumulators. You have used the solution in this context for getting the training done and reduced precision training with Brevitas. And Xilinx has, with Michaela's team, built open source available, a compiler to get to our FPGAs. The other part that I want to say a few words about is further integration. So you want to integrate this kind of technology with control processors. Like I said at the beginning, I have maybe network interfaces or general purpose control. I have FPGA style technology. And in the radio digital front ends, I want to have D2A and A2D interfaces so that I can drive the antennas that are behind there. Another technology that we have is the new, what we call adaptive compute platforms, which are the same idea, general purpose processors, FPGAs, network interfaces and high-speed I/O interfaces, but a new technology called AI engine. And I want to spend a few slides on that and then we conclude. So AI engines are actually an array of instruction set processors that are tuned to be able to do vector instructions and vector hardware for the application domain of both wireless applications and machine learning. And it's basically a processor in the conventional sense, and it has C and C++ compilers, and Xilinx is building also additional frameworks for machine learning with these. What are they? They can talk to its neighbors, they can do the compute on its own. The first product that we have in the market is 400 of these 1 gigahertz processors, and they have terabytes of communication and teraops of compute and a software development environment. Let me give an example of what we do in the wireless domain, and it's publicly shared that, for example, a company like Samsung is building base stations with this. You can do multi-carrier, multi-rate filters, you can do beamforming with that, and you can do fast Fourier and FFT with that. But you can also do machine learning with that. And the combination of machine learning and wireless applications in the speeds that I've shown are very important. For the machine learning part, you want to use the Xilinx tool flow that will get you from TensorFlow or PyTorch all the way down to code running into these processors. And it's an ongoing, exciting field that is applied for wireless, video, and other machine learning applications in a combination of conventional signal processing and machine learning, all integrated in one or more of these devices. So in conclusion, you have many opportunities for artificial intelligence and in particular deep neural networks in communication. I would highly encourage you to think of it not as just a program you need to write in TensorFlow or PyTorch, but as a program that is a part of the total integrated signal processing. And you could imagine that the question is not to train just your model, but to train the whole chain of signal processing in combination for best results in the sense as defined by accuracy. There's a whole opportunity for small or fast neural network implementations that really work well in this domain. There's a further integration of these frameworks with the signal processing, and signal processing teams usually would use MATLAB, but you can now think of it as TensorFlow and PyTorch integrated with those signal processing environments. We talked about it, the need for data sets, and I've shown you that there are novel programmable hardware technologies coming online from Xilinx and others that will help you solve this in the field, in practice. In short, these are exciting times with many new opportunities. Thank you.
Thank you very much, Kees, for this very nice presentation. Let me ask you one question. Machine learning is going to impact many new fields, or most fields or all fields in society and business. What do you think will be the impact of machine learning on standardization, on the process of doing standardization? The way standards are being done right now is people submit a paper and then they go to a standards meeting, a physical one or an online, or they discuss via email. And then they try to come up with a compromise when it comes to defining the standard for protocols, say. So what do you think will machine learning do to the way people are trying to get standards? Do we still need people to do standards, or do you think that eventually this could even be taken up by machine learning?
There's two pieces to that. One is in the conventional process of making standards. It's not unusual that you come with proposals plus a first order proof or example that this is possible to be implemented realistically, right? We can come up with outrageous algorithms, but then everybody goes like, let's not put that in the standard. What I think is extremely important is that we come up with proof points using the integration of machine learning and neural networks in the communication chain to show what is possible and reasonable at that point. And so that's one where this conventional standards process is benefiting from the opportunities that machine learning could bring to that whole domain. The second part of your question is, can we abolish this and have just an online negotiation the way current large providers do trading for prices on Google advertising or so on. And basically, it is a fully automated process and we can accept the standard. Unfortunately, not yet, because quite often this requires a judgment call. And the judgment call is experts in the field come up with what is reasonable. And we don't have this final formula that here's the best performance or the best accuracy. And after that, we can just fully automate it. But I think the impact, as I said, can be that we come with very interesting novel solutions for the domain.
Okay, thanks very much. Thank you very much for getting up early. Thank you very much for sponsoring the challenge, for providing a problem statement. And it would be great if we could welcome Xilinx again next year as a partner. Good. So we are coming to the end. We have, let me just tell you where we're going. We do a quick survey. We want to see whether you like this session, this episode today. We do something called the Net Promoter Score. Then we do the awards ceremony, and then we're done. And actually, we want to try to take a photo of the winning team. So we try and do that, and then we'll close. So can I ask my colleague Bastian to show the what's called the Net Promoter Score? So that's we want to get your feedback whether you like today's sessions. The question is, how likely are you to recommend this webinar to a friend or a colleague? You have one choice. So 10 is if you really, really like it, and 1 if you don't like it. So we'll give you about 15 seconds. If you just take a couple of seconds and you click what you think, what you would recommend to a friend with respect to today's episode. Good. And with that, we now come to the award ceremony. And I am going to announce a couple of awards, and then Chesa will announce the big winners. So I'm going to announce what we call the Mentors Encouragement Award, and then the Honorable Mention Award, and then the Public Best Solution Award. So Gino, are you ready with the ceremony? Okay, so we go for the Mentors Encouragement Award. And so this is an award that mentors gave to young student teams who were engaged in the process. And we have 2 awards. They're called MLab RL and the winners. So those 2 student teams get our Mentors Encouragement Award. They receive a certificate. There is no prize money attached to that, but we hope that they continue and participate perhaps the next year's challenge. Then we move to the Honorable Mention Award. So we will have 6 teams who will receive the Honorable Mention Award. These are Orion, Data Explorers, the Digi Pioneer, SSN ITU, the Sixth Sense, and Automata. So all these 6 teams receive a certificate, and they will receive each a cash reward of 300 francs. And then we move to the public best solution, that the public was their favorite solution. And this is Team SSN ITU. So congratulations to all of these teams. And now I'm going to hand over to Chesa, who will announce the big winners of today. Chesa, are you back?
Yes, thank you very much, Ryan.
Yeah. Okay.
Congratulations, all of you. I followed all your presentations. I learned so many things, get nice ideas. My sincere appreciations, Mr. Keith Bisser, of your insightful keynote speech. As a techie myself, I learned so many things. Okay, so we are now this year, the challenging features, several really innovative solutions. So it's my honor to announce 3 teams have been awarded runners-up prize of 1,000 Swiss francs each and a certificate. And the winners are Team MLGrass, Team Amber, and the Team SoftGNN. So three teams now is at 4th grade, and then moved to the 3rd prize. 2 teams were so very, very close. So the judge panel is now decided to award both of teams with a cash prize 2,000 Swiss francs each and the certificate. The winners are Team Federation S and the Team Automata. 2 teams, congratulations. And move to the next is the silver champion. Silver champion. The winner of the 2nd prize will receive a cash award 3,000 Swiss francs and the certificate. The winner is Team Piranha. Congratulations. Very interestingly, this team is comprised of a single individual. Congratulations. And now I believe all of you are waiting for that. Is 1st prize, this gold champion. This team will receive 5,000 Swiss francs and the certificate. So the gold champion of year 2021 IQ and AI machine learning in 5G challenge is Team Bacalio Net. Team Bacalio Net. Sorry, my bad pronunciation, but it's difficult, but Bacalio Net. Congratulations to all winning teams. So back to you, Reinhard.
Okay, thanks very much, Chesa. Congratulations to the winner. Let's try to take a photo. Can I invite all the winners first of the big cash prizes, and then we get everyone on board. So can I invite the winners of the runners-up, 3rd prize, 2nd prize, 1st prize to turn on the video? If you so wish, then we take a photograph. Yeah, okay, let's, hello, no, there are not that many yet, but that's okay. Can I invite everyone who participated, who was showcasing their solution, one of the 13 teams, can I invite everyone to turn on the video if you so wish? And then we try to take a photo. Okay, a couple more. Okay, all right, okay, thank you for that. Good, so we'll take a photo shot, whoever is available. My colleagues are taking photos right now. Thank you very much. But we'll do a little bit of photoshopping perhaps afterwards. Good. Thank you for that. And we are coming to the end. Let me see. Oops, what's left here? We're coming to the end, and that is for Chesab to say the closing words. So, Chesab.
Yeah, thank you very much again. My sincere thanks to all participation in this challenge. I believe everyone is already winner. All you are winner. You brought up this your ideas. You brought to your solutions. I really appreciate all your participations. So I'd like to invite all teams, not just the teams who presented today, but all teams to submit your paper with your original research to the ITU journal on future evolving technologies. The call for paper has already been launched. As I said, deadline is the 31st of January next year. The leading guest editor is Aldevaro Clautao. So the ITU journal is a peer-reviewed journal, which ITU started a bit more than a year ago. So we are all on ambitious road towards getting an impact factor. So your submission of paper is quite helpful for us as well, and also the expanding of this your visibility of this your works. And please stay tuned for the announcement of the year 2022, as Vishnu said, of another challenge in next year. So friends and colleagues, let me express my gratitude again to all the more than 1,600 participants of the challenge, the jury members and the members of the Challenge Management Board, the hosts of the problem statement, our sponsors, Xilinx and the Ministry of Science and ICT of the Republic of Korea, our technical partner of the challenge, AIIA, and Thomas, Vishnu for managing the challenge, as well as many colleagues working invisibly backstage. So it's now time to an end. I wish you all restful holidays and all the best for the new year. Say Merry Christmas and a Happy New Year. Thank you very much. Bye for now.
Okay.
Thank you and bye-bye.
Bye-bye. And we have a closing video. Gino, if you kick that off. Okay.